Okay, hi everyone. Thanks for coming. Brief bio to start with. This is my talk about building apps for Alexa. My name is Sarah Saunders. I'm a software engineer at Capgemini. I did a computer science degree in the 90s, and I was a Java dev for a while. Then I joined Capgemini, and it's given me an opportunity to work with a lot of different technologies since then, partly because usually you travel to the projects that you're interested in as a consultant, but because I have children based in Manchester, I've adapted instead to work to whatever technologies are going in the Manchester area. So, I think it's made me a bit of a jack of all trades with a sort of implied master of none there. And what I'm going to talk to you about today is building Alexa skills. I went to an Alexa Dev Day, which was the second best free Amazon conference I've ever been to. I'm really impressed with the way that Amazon make all their technologies very accessible. You know, their marketing is excellent and their APIs are excellent, things like that. So I was really inspired by the Dev Day, and I wanted to build my own Alexa app. And I was trying to think, what's a good scenario for Alexa? I don't think there are really that many, because voice interface is actually surprisingly slow. You know, more often you'll be able to communicate via a keyboard much faster than you'll be able to talk. And listening to the response, you can read much faster than you can listen. So the subset of use cases for Alexa I don't think are huge. But I was thinking, you know, maybe if you were trying to psychoanalyze yourself, you're trying to be introspective, you'd want to take that time. So maybe Alexa would make a good analyst. So that's the hypothesis that I'm going to investigate today. And I discovered that there is an open source equivalent of the Myers-Briggs personality test. And so I thought it'd be great if I could write some code that would get Alexa to talk you through the personality test and then give you your personality type at the end. So what I'm going to do today is I'm going to do a demo of this, and then I'm going to show you how it's made, because has anyone built an Alexa app before here? A few people. Yeah, I don't know if you agree. It's quite surprising, you know, what you think it does and what it actually does. So we'll have a drill down into how the demo works. So first of all, this is what I decided to build: the open extended Jungian type scales. So as I said, it's an open source version of the Myers-Briggs personality test, which is based on a theories of Carl Jung, who decided that there are these personality types which are opposites. So you can either be introverted or you can be extroverted. So, you know, you're not one or the other. They're different extremes. And Myers and Briggs extended on this. They added the fourth, perceiving, judging personality type. And what the OEJTS is a series of 32 questions that you answer, and then it will calculate your personality type. Did anyone come to DevOps last year and see the Capgemini stall then? Okay, yeah. Yeah, the Capgemini people did, yeah. So, yeah, that's good, because that's what I'm going to talk about, so you won't be hearing things twice. So the challenges are that the Myers-Briggs test requires you to answer the question on a scale of 1 to 5, whereas when you're talking, you know, if Alexa says to you, do you make lists or do you rely on memory, you're not going to reply 4, you're just going to say yes or no. So what I needed to do was translate that yes-no into a 1 to 5 scale somehow, and then obviously get Alexa to recognize the answers and process them accordingly. And then, yes, this is supposed to be fun. You know, science has sort of swung away from Jung's opinions, and for reasons I think quite well summed up by the author Neil Stevenson, who was writing that the German phrase for heroin addict, the direct translation into English, would be morphium-seeky. So he's a bit morphium-seeky. He's not a heroin addict. And if you think of the power of the language, if you're saying you are an addict, it's sort of putting you in a box and saying it's out of your control, you know, it's not something you can do anything about. But if you phrase things as he's a bit morphium-seeky, it suggests it's within your control to alter that. So, you know, the personality type scales should be treated as a bit of fun, and we were trying not to offend anyone. More on that later. So to make it a bit more fun, I thought, well, we'll map those types to software engineering personality types. So this is what we did for DevOps last year. We had different images for the different type of person that you might be. You know, if you're more creative, does that make you more likely to be a front-end dev? You know, if you're a control freak, does that make you more likely to be DevOps? Don't know. And then, yes, accidentally branded our senior developer a front-end developer. He hasn't forgiven me yet. But that was just to try and keep it fun. Remember, it's not hardcore science. You know, if it says that you're introverted, don't get offended. So these are the types of questions that I had. I turned them into a JSON file, so you can see that there's two ends of the scale, and then you can imagine the kind of answer. If you say, are you skeptical or do you want to believe? You probably say, I'm usually skeptical, or something like that. So you would use a word from the question in your answer. So I thought, okay, this is probably possible then to get Alexa to recognize the answers. And so now we come to this problem of trying to map yes or no to 1 to 5. And this is where you already start to hit up against some of the limitations of Alexa, because the file that gets sent to the piece that you control in the API is only text. So you lose all the tone of the conversation. You don't know if the person is shouting or whispering. You lose any kind of pauses. You know, did they take 5 seconds or did they go, oh, I'm sure? Because if you did have those pauses, you'd be able to say, oh, right, well, they answered quickly, therefore we'll put them on the one end of the scale. Can't do that. You can't pick up the filler words. So if they say something like, well, probably, that's lost by the time it gets to your API. So all I had was the text answer that they'd given. And so I thought, well, I could do sentiment analysis on this text. And if they said yes, that would be a very positive answer. So then I could map and say, well, I'll give you a 1 for that. And if they went, not always, that's fairly negative, so that could be maybe a 4 on the scale. So the idea was to use a sentiment analysis API to judge what kind of response the user had given. Does anyone know anything about sentiment analysis? Yeah, a couple of people, yeah. I didn't at all, so sort of, you know, one of those, how hard can it be? Started to look into it, and obviously we're standing on the shoulders of giants as computer scientists, because the study of natural language processing is hundreds of years old, and people have gone to great lengths to try and analyse what we say and how we say it. So there's that base level of natural language processing. Word segmentation, not all languages have a space between words, so you've even got to get past that step 1 of where are the actual words in this. And then you've got parsing of the sentence. So I'll show you how Google does that later, which is a nice way of looking at it. Stemming and lemmatization is like, so say code, for example, coding, coder, coded, cod would be the stem, but the lemma would be code. So you need to know what's the root word here so that we know the context of what we're evaluating. So once you've done all that hard bit, then you've got the sentiment analysis. And there are different attributes that you can look at there. You can look at polarity, positive or negative. So that could be fairly simple. You could just have, you know, a dictionary and map the words, are they positive or negative? And there are much more sophisticated, fine-grained ways of getting scales of 1 to 5 on the polarity of words or sentences or entire documents. And then you have to look at subjectivity. So if you imagine when you're talking, you might say, I didn't like that ice cream. Or you might say, well, the ice cream was really cold. Or, you know, so the way that you're talking about things, you might be objective. And you say, oh, he had an ice cream. And, you know, the ice creams are really cold. Which bit of that is relevant to the sentiment analysis? So there's a whole, you know, PhD theses of work around identifying the subject to identify whether it's positive or negative. And then there's, who is the opinion holder? Are you talking about the thing you don't like? You know, he doesn't like ice creams, or I don't like ice creams. Do you say it explicitly like that, or do you say, oh, well, last time I had an ice cream, I was ill? So that's kind of implicitly that you don't like them. So what I wanted to point out really is it's an awesome, huge, great subject area that I know very little about. But in a wonderful modern age, there are APIs that you can just go to and ask, what's the sentiment of this? And they will reply. So I've picked out 3 here. My favourite is this one, theysay.io. If I go to the website. because it tells you absolutely nothing at all on the website about how it works. It could just be, I like to think it's a console into an old people's home, where whenever you make a request, they go, they sound miserable and they give you a negative. But you can try it out here. So if I put, I'm dead happy about that. So what do they think of it? I'm just hoping I've got internet here, because... yeah, okay, yeah. So you can see it's gone negative, probably because I put the word dead first. So it's like, well, that's negative. So then if I change it to say, I'd be happier dead, which is, I think, is negative. But because happy comes up first, it's positive. So I mean, that's probably a sort of lexicon, isn't it? It's probably some dictionary where they're just taking the words. But then if you look at Google, I mean, a small story from one of our projects for Google that I'll paraphrase. Basically, we wanted to do some performance testing. And I think we were using Amazon at the time, so the guys phoned up Amazon and said, oh, can we have 10,000 servers, because we want to do some performance testing. And then they were like, oh, well, you can, but we're going to have to wrap them up, so give us a week's notice or so. And we haven't got a week, so phoned up Azure, phoned up Microsoft. Have you got 10,000 servers? And yeah, but it's going to take us a while to get them going. And then they phoned up Google, and Google were like, don't know, give it a go. So I just think that Google is basically mainly run by AI now. But so this is their... so if I try this one, I'd be happier dead. I don't know if this... Maybe that's not the right...
I'm not a robot.
Oh, yeah. Is it? Oh, it's still going. So you can see the sentiment here. So it's again, it's gone pretty positive, hasn't it? But you know, it's not too sure. But then you can see here the way that it's broken down the phrase, and it's done all the things I was talking about with the natural language processing. So you can see the effort that goes into these tiny calculations. I will try. I'm dead happy about that. Yeah, about that. So what's it going here? So yeah, so it's slightly more accurate. And then there's another brilliant one, which textprocessing.com is their website, and you can just make curl requests to their endpoint. And this one's free, completely free. They say.io is pay as you go. Google has free tiers, but then you pay a volume. But this is completely free. It's they tell you what it is. It's a neural network that runs it. And if I curl, I'm dead happy about that. So it's gone slightly more lightly on the positive side, and I'd be happier dead. It's gone slightly more in the negative. See, that's slightly more accurate. But you can see how difficult the subject is, and so I decided to use theysay.io. It made me laugh more. So what I want to do now is a demo of the app that I built. I've got a few choices with this, because the IDE is online. I haven't got an Alexa with me, but I'll show you the brilliant online IDE has a test page where you can just test your app. And you can either type or talk into it. But if the Wi-Fi lets me down, I have a video of my daughter doing it, so you can watch that instead. Have I got any volunteers of anyone that would like to come and take the personality test? Come on, Matt. Plant. Okay.
We totally don't work for the same company.
Right, so you trigger it with the launch request. You can either type or talk. If you want to talk, hold the button down and talk. Yep. So if I just put analyze me, and then I'll hand it over to you.
Welcome to this pseudo-scientific personality type quiz to determine your open extended Jungian type scale. To start, say start quiz.
Start quiz.
I'm going to ask you some questions to determine your Jungian personality type. Okay. Now, do you prefer to make lists, or do you rely on memory?
Prefer to make lists.
Aha. Would you necessarily say that all time?
Yeah, most likely.
Okay, now, are you skeptical, or do you want to believe?
Totally skeptical.
Would you necessarily say that all the time?
All the time.
Aha. Do you think you would always have that reply?
I didn't map that one.
Yes.
Okay, now, how about time alone? Are you bored by time alone, or do you need time alone?
I definitely need time alone.
I see. Would you necessarily say that all the time?
Don't worry, there's only 7 questions.
Okay, now, do you accept things as they are, or are you unsatisfied with the way things are?
Always completely unsatisfied.
Do you think you would always say that?
Maybe?
I see.
Ooh, I didn't map maybe.
That all the time.
I guess.
Okay, now, do you keep a clean room, or do you just put stuff wherever?
It's very clean.
Okay, now, do you think the term robotic is an insult, or do you strive to have a mechanical mind?
I want to be robotic.
Interesting. Are you sure about that?
No?
Okay, now, would you describe yourself as energetic or mellow?
Very energetic.
I see. Are you sure about that?
Not completely.
Thank you for taking the quiz. Your personality type is I.
That's actually quite
ST.
close. I've done that before. I am a ISTJ. I'm a server-side developer. That's
You
literally
are.
what I do for a living.
Thank you, Matt. So you can already see from this that Alexa is not a very good analyst, and trying to do 32 questions like that would be mind-bogglingly dull. And you're probably thinking, well, there must be a better way to structure it. So what I'll do now is show you how it's set up, and then you might start to understand why it was necessary to structure it like that. Right, back to... So these are the 3 components of an Alexa skill. A skill is the name for your own Alexa app. So you have the Alexa voice services. So this is the bit that sits in your home. So it sits on the Echo that you have, or you can... they have a C version that you can put on a Raspberry Pi or a PC or a Mac. I couldn't get it running on my Mac, but I'm sure it's possible. And what that contains is the logic for the wake word. So it will have something that's constantly listening on a port, but it won't start recording until it hears that wake word. So the 3 wake words that you can use for Alexa are Alexa, Echo, and computer. But theoretically, I reckon, we were debating this earlier, because the code runs on your PC, you should be able to rewrite it to recognize other words. I couldn't see anything in the code where it was double-checking with the servers that your wake word was on the approved list. And so when the wake word is picked up, Alexa will start recording, and will record for 8 seconds. So I don't know if you remember, a while back there was a guy in the House of Commons who had his Siri on dictate mode and had recorded the whole session by accident. You couldn't do that with Alexa because Alexa will cut off after 8 seconds. So an interesting feature. And then what it does after those 8 seconds, it saves what it's heard as a WAV file and sends that off to the Amazon servers. And then on the Amazon server side, where the magic happens, and that WAV file will be translated into text. And what was quite good about that test page is you could see how effectively it was doing. It was okay, but it wasn't perfect. And so then, once you've got that into text, the next point at which you, the developer, can step in is the invocation model, also called the Alexa Skills Kit. And this is where you define, in JSON format, the flow of the conversation that you're expecting. So there's a concept of an intent. So the intent is the thing that you've just said to Alexa. So, a really simple one, ask name intent. So you might say, Alexa, what's your name? And that would be your ask name intent trigger. And then the other concept on this side is the concept of a slot. So what the invocation model does is it's kind of like a sieve, and it will sieve out from all the text that has come through in your WAV file the pieces that are relevant to your back end. So the slots are the bits that you want to fall through the sieve. So response to what's your name. So if Alexa asks you what's your name, the response would be in the format, my name is name, or I'm called name, or I'm name. And that name piece is called a slot. And a slot has a type. And Amazon has predefined a ridiculous number of types. There are types for sports, countries, names in all different languages, you name it, and there probably is a predefined Amazon list of everything that could possibly fill that slot. It's incredible. And so this is the way in this invocation model that Alexa is trying to recognize what it is that you're asking and figuring out how to respond. So once you've defined your invocation model to sieve out these slots, the slots are passed to the back end, which can be anything. You can write it yourself. The default Amazon hosted one, if you're setting up a skill, is a Lambda function, which works really well. Be node by default. And there are two methods. There's a can handle method, which gets every single intent. And so in the can handle method, you just say, all right, is this my intent? In that case, return yes. If it's not, then pass it through. And then there's the handle method. So if can handle returns true, then you can go into handle, and that's where you can do your business logic. So that's where I can do my calls to the sentiment analysis, for example. So we'll have a look at the one that I wrote. So we'll have a look at the invocation model first. Right, so the invocation, you can see to start with, you say, analyze me. That's the kind of thing that you might say to trigger this. And then the quiz intent is the first one, because what Alexa said was, when you're ready, say start quiz. So the quiz intent answer is going to be start a quiz. That's the kind of thing that will trigger that. And then you're looking for the answer. So the answer intent here is defined as, I think I, or probably I, all the things that Matt was saying. I had to create a list of all the things you might possibly say to answer the question. And then you can see my slot here is quiz answer, which is my custom type that I've defined. So if we go down to the types, you can see quiz answer here is defined as an assertion. And I've created that myself. And I've done this huge long list of all the possible answers to the question. So I've had to create that myself. There's not really much magic or much done for you when you're building the skill. You have to sit down, think of everything that someone could possibly say, and define it in your invocation model. Otherwise, it won't get picked up. And then after that, the next step that we want to do is we want to do our sentiment analysis. So we want to say, are you sure? So that's this assertion intent. And I've got my custom decision type. And then I've listed here all the things under assurance that might possibly be said in response. And again, when Matt said something outside this list, it just dropped through to the question again because it didn't recognize it. So it's a real pain to try and set up any kind of complex conversation because you have to think so far into what people could possibly say. So I think a lot of Alexa or any voice service design skills is going to be around designing the questions in a way so that they're closed, so the answer is as close to yes or no or a specific object as you can, because as soon as you have an open answer, it's too difficult to match on the response. So that's the invocation model. And then we'll go through to the Lambda side, which is pretty dull, really. But so you've got your can handle method. And this is all of the stuff to calculate the response. So here we are. So here, can handle an assertion. If it's an assertion intent, then return true. And then when I want to handle it, I have to get the slot, and then I have to, actually I haven't got the code in here to call it, but that's where you make your HTTP code out to get the sentiment, and then you do your analysis, and then there's, when we were doing the test, I don't know if you noticed the the code, you can see that there are attributes passed back and forth between the Alexa skills kit and the back end. So you can set values and then they will be there on your next call. So you can maintain state throughout the flow. So I think you can see by the limitations of the invocation model how I had to set the quiz up in that way. I couldn't just listen for a bit of content, run some analysis over was it positive or negative, because you really have to pin down the conversation style in the ASK. Right. Oh, and security is always worth mentioning. So there are obviously the 3 different pieces, and you need security between all 3 of them. If you use an AWS Lambda backend, then it's all set up for you, but basically it's OAuth between each hop. So you register the skill with your Amazon account, and then you have to permission your device to be able to call that skill, and then you have to permission your skill to be able to call your backend, and so on. So that's been carefully thought out, and it seems to work pretty well. Right, so yeah, drilling down a bit into the intents. I think we've already done this because I've looked at the code that I have. So this is the JSON equivalent. We've been looking at the sort of GUI. But you can see you've got your invocation name, and then you've got the list of intents. There's a set of standard Amazon intents, which would be help, cancel, quit, or stop, it's called. And then you put your own custom intents in, and you give them the type, and then you create your own types, and you give them a list. You can also have synonyms for it. So if you think someone might say make a list instead of make lists, you can put a list of things that are synonyms for your value. So you don't have to have multiple answers. You could have 3 answers with lots of synonyms for those answers. And custom types are quite interesting. When I was working on this last year, there was this concept of Amazon literal, which was a sort of base type, and then you could extend from it. So I was having a play with it. They don't have the Amazon literal base type anymore, but this idea still stands. You can see in the samples here, I've got 3 ways to call it. You can either just reply with your name, you might do, or it's, and then your name, or my name is. So, and what I found is if you use a non-custom type, a non-Amazon type, and you have it in a structure, it will still be recognized. I'll just do a demo of that. I wrote a really simple skill called favorite country. And if you look at the... actually, I want to look at the invocation model for it. Go to the raw JSON. So you say, what's your favorite country? And it's looking for the reply of, I like the country, my favorite is, it's, or just the country name. So either it's in a sentence or you say just the word. Now, when I trigger it,
what is your favorite country?
Brazil.
Hello. Undefined is my favorite too.
Because it's picked up resume and not Brazil, it doesn't know that it's country. But if I said, I'm going to type again. Tree.
What is your favorite country?
My favorite country is wine.
Hello. Wine is my favorite too.
See, it's recognised the word there because it's in a structure, so it can match it. But when we had here undefined, it was because I'd only said the word, and so that wasn't enough information for the invocation model to say, yep, this is definitely the slot we're looking for. So it was quite a cool little bit of sort of Alexa hacking to see what it's doing in the background. Since I wrote this skill, Alexa has introduced a new way to have a multiple slot conversation, which is this thing called a dialog manager. And so I had to play with that because I thought actually that would work a bit better. Because what you do is where it says enable auto delegation, instead of you having to say, I'm running out of time here. Instead of you having to say, this slot is filled by this question, you just give Alexa a list of slots and a list of questions, and it will keep asking the questions until it's filled in all the slots. So it makes it much easier to write that kind of a conversational flow, and it's very cool, but it still doesn't help me with the sentiment analysis piece because I'm still not getting any context around what those answers are. And I've also lost my hook into adding the question. They do have a confirmation on this, but it's always, are you sure, yes, no. So again, doesn't really help. But yeah, dialogue management is very cool. So lessons learned from this, voice interfaces are slow. They're not always that useful. You want to use them when you want somebody to take time over their response, or when when you're using your hands for something else. When you're cooking, turn the oven on. That kind of thing is brilliant. But if you're just building a skill for something you do day to day, it's probably quicker just to type it. And I think the big skill set for this is going to be understanding conversation structure, English, the kind of things that we computer scientists are not necessarily that good at. So it'll be an interesting future for voice UI. Right, I'm out of time. Thank you very much. I'll be on the Capgemini stand if you've got any questions about